Hi guys, here's another update. The devices are getting more refined and more powerful. Still being run off of a 1.8 watt signal generator. We've got almost 12 watts on the output. We can run this bulb almost full brightness while we still have wireless power. Like, it's great, and the range is insane. Come on, focus. Whoops. I don't even need capacitors anymore. It's just nothing but straight coils. The more strands you have, the better on the wire. Notice how this is a center tap primary, and it's perfectly in center with these two coils. So this end is hot, and this end is hot, and they're wound in opposite directions. And the power comes out one end here. It's all rectified to DC. Here's the other end. Goes to some small capacitors, and it runs a light bulb. It's that simple. It couldn't be any easier. Like, you should not be able to get that amount of power from a signal generator. My input's 1.8 watts, and my output is close to 20. Sometimes it takes a moment to charge up. There it goes. It's also very sensitive to tuning. Let's see if I can show that by touching different spots. It got brighter there. The way you ground this system will also yield more or less energy. I think I can also run this neon tube too in there. Guess we'll find out. Maybe it'll ignite. Oh, yep, it ignited. So we got the neon tube ignited, the light bulb running, and still wireless power. Like that. That's crazy. How you doing, buddy? That's my dog walking by. I mean, look at that. You shouldn't be able to get that much power out of this system. It has to be run off of a DC pulse. That's the key. And I'm at a very high frequency. The range is still pretty good. And if I ground a wireless pickup coil, it'll get brighter. Whoa, you can see like the energy flowing through the tube. That's kind of neat. There's like waves of energy flowing through the tube. Yeah, I mean, it doesn't get any more simple than that. If you look inside the device, just a hollow 1-inch PVC pipe. This is the primary coil that runs the secondary, which is the transmitter. I guess you could kind of call it a dual pole transmitter, because the two ends are really hot. And I just simply took the output from the two ends, turned it to DC, and ran a light bulb. And it also still has wireless power capability, which is crazy. Yeah, it also can be run off just one wire, the positive, but the power level will be lower. So I can run this off of just one wire, but the power level is much lower. And when I run it off one wire, it doesn't consume power at all, which is very interesting. I connect the other wire, it gets much brighter. Well, that's interesting. The light bulb lit right up. Usually I have to unplug the light bulb, let the caps charge, then I can plug the light bulb in. Yeah, it's completely run off the signal generator. Plug it, shuts off. 5 watts. Plug it back in. 6.7. So yeah, this thing can only put out 1.8 watts max from what the manufacturer says. Plug the light bulb in. There we go. That's the brightest I've ever seen it. And we still got wireless power. And a neon tube lit. That shouldn't even be possible. You know, I wonder if it can run a 120 volt lamp. Probably can. Probably not at full brightness. We'll see what happens. First time doing this on camera. Huh, yeah, it runs it. Not at full brightness, but it runs it. Only consuming 1.8 watts. That's pretty friggin' bright for 1.8 watts. And there, yeah, that's not 1.8 watts. There's no way. That's almost 12 watts. Neon tube still glowing. Plug the regular light bulb back in. I can see it. There we go. No, still can't see it. Okay, there it is. I'll plug the regular light back in. It's probably not good to run it off this power. This isn't the right type of power anyway to run a 120 volt light bulb. So yeah, I've demonstrated once the signal is being produced, the wireless pulse signal, you can just endlessly tap off of it. Like, there's no limit. So far, this seems to be the most efficient design. The transmitter is 30 inches long. The coils coming up to this point, right in the center, are wound clockwise. The coils going this way in the center are wound counterclockwise. So they're opposing directions. They're all brought together in the center with diodes. 1N4148 diodes. I'll include schematics too. They have to be diodes. The gain comes from... I kind of split this up into quarter wavelengths, each of the coils. And there's diodes on the end of each output, as you can see. Basically what's happening is one coil energizes another coil, and each one has a diode coming off in an opposite direction, like this. See? One diode faces that way, the other faces the other way. That's really all there is to it. That's literally all there is to it. One diode off the end of each coil in opposite directions. And I'll show that without those diodes you will not get energy, which is very interesting. So here's the meter. Put the meter right here. I'm going to get some clips. Try to do all this one-handed. Alright, I got some clips. So I'll come up right before the diode. And you see when I clip this on, it gets brighter because it acts as an antenna. I think these coils pick up extra energy from either the environment, the sun. It's got to come from somewhere. So yeah, I hooked up the meter to the coil before the diodes. There is no output. And for a while, I thought that the wireless system wasn't working when I never had diodes hooked up. As you can see, there is no output when I'm connected to the coil before the diodes. I go to AC, still no output. Now I connect it after the diodes. Boom, there's the output. And the voltage is a little low because it's running the LED, which acts as a load. No AC, just DC. They kind of act as a half-wave rectifier, the diodes. Now, the reason you have to have the diodes coming off the end of the coil is it prevents detuning. Your receiver coil should either be a quarter the size of the transmitter, half the size, or the exact same size as the transmitter to get the most energy gain. At least that's what I've experienced. Yeah, there's the output. Still running all these other sources of light, not dimming, not getting dim whatsoever. That should not be possible off 1.8 watts. Do a current check. Move it closer. You see the current goes way up. Get it nice and close. We almost got 5 milliamps. This even got brighter. They're like feeding off of each other. That got brighter. We'll go back to voltage. That LED looks like he's about to pop. Move him a little further away. This is the most effective design I've ever made so far. Really interesting. I'll try and put another tube in here and we'll see what happens. See if this can light up too. One of these tubes is blown. I always manage to grab the blown tube, guys. I can have like one blown tube out of a pile of 20, and I managed to grab it somehow. No, maybe not. Maybe it won't get lit. Sometimes they're picky. It really likes the big ones, though. Huh, interesting. See, I'll do a range check with the wireless. Barely 2 feet. See if I can light it outside. No, not out here. It's about 2 feet at the moment. Huh, that's kind of cool. Yeah. My frequency is 3,250,000 pulse, DC pulse. That's 3.25 megahertz. You can see it's highly sensitive to tuning. I will go away from 3.25 and everything goes out. I go back to 3.25, comes on. Yeah, 3.25 is my most energetic frequency. Yeah, was there? I don't think there's anything else I wanted to discuss. I think I covered it all. Yeah, to sum it up, you need 2 diodes coming off the end of each coil, opposite directions, 1 N4148 diodes. Center tapped primary, it helps, you know, sometimes you ground it, you get a little boost in power. You can stick a rod in the ground, connect it to the center, it gives you a little bit of a boost in power. counterclockwise wound, clockwise, bonded in the center with the diodes. It's literally no more complicated than making a bunch of these coils and just wiring them in series. So when you do that, the diodes are connected in series with each other in opposite directions. Very easy, very simple. You can kind of see the way they're connected in series right here on one of them. See? One goes up, one goes down. This device is so simple. I think a 10-year-old could build it if they were dedicated enough. Way it was wound, I just took a drill, bought some kind of adapter. Just fits on the end of a PVC pipe. Here's the wire that comes off of it. I'll just put the pipe in there, tape it to it. But yeah, that small device outputs more than that bigger device from the past video. I kind of was still figuring out what the most effective design was for the most power output. But yeah, I just pop the PVC pipe on the adapter and just start slowly spinning the drill with this wire. I believe it's 28 gauge. Yeah, it's 28. This thing is nothing to it. It's just a bolt. It's just a bolt on an old cake spool. Just spins. Yeah, just a drill. Real complicated. My scrap wire bag for my job. Okay, I think I'll put the scope on it and we'll see what we get. This was kind of a Don Smith spin-off device with kind of like the Tesla magnifying transformer principles built into it, where everything is a quarter wave, a half wave, or a 1/8 wave based off of each other. It's all got to be a harmonic of each other, is what it said in the book. It's very simple. You can figure it all out with just a measuring tape. So for example, this was 30 inches.